Good morning students. Today we are going to discuss few important topics, and these topics are very important from experiment point of view because both the topics are in your syllabus regarding experiment. Now the first topic which we are going to discuss is your meter bridge. Now why it is known as meter bridge we will come across afterwards. Now this meter bridge works on the principle of Wheatstone bridge, and Wheatstone bridge principle already we have discussed. Now in the circuit diagram you see there is a two gap, one on the left side and another on the right side. Now on the left side we have enclosed the gap by the resistor capital R, and we have symbolized with the rectangle. Now the symbol denotes that it is a resistance box, and the resistance box basically comprises of number of resistors, and S is your unknown resistor basically. We denote as your capital S, and basically the principle of the meter bridge is to define the value of the resistance of the unknown resistor. Now a galvanometer is connected and the free end is slided over the wire of length 1 meter, which we define as your AC. Now on the length AC we will slide the free end of the galvanometer, and one end is fixed in between two resistors capital R and capital S. Now we will stop the sliding when the galvanometer shows zero deflection. Let me consider B is a point where the galvanometer shows zero deflection. So under that case the bridge is said to be balanced, and then we can apply Wheatstone bridge principle. And under Wheatstone bridge principle the ratio of the resistance capital R and the resistance of the wire of length AB should be equal to the resistance of S and the resistance of the length of the wire PC. And the source is connected definitely between A and C with the EMF E, and the key is there. So current will flows through the wire from the source. Now what we have written, let me write. Meter bridge is the let me read out. Meter bridge is the practical form of Wheatstone bridge. It works on the principle of balanced Wheatstone bridge. Now if the galvanometer G does not show any deflection, that is balanced, then balance means no current through the galvanometer. Then ratio of the resistance, that is capital R by resistance of the length L. If rho is the resistance per unit length, then L rho gives you the resistance of the wire of length L, should be equal to the resistance S divided by resistance of the wire of length 100 minus L rho, where is rho is the resistance per unit length. So if we cancel out rho, you will get R by S, L by 100 minus L. So from here we can calculate S provided we know the L and R. So this is very important formula. S is equal to 100 minus L by L into R. So thus knowing L and R, resistance of the unknown resistor S can be calculated. So in numerical we are going to use this formula, and also in experiment. Now you do have 3 experiments from the meter bridge. We'll come across later on during our practical class. Now we are trying one numerical based on the formula which we have defined. So in the numerical it says that in the meter bridge experiment setup, the null point is obtained at distance 40 cm from end A, that is B is at 40 cm. So number one expression we are going to use this one, R by S equal to L by 100 minus L. So R by S equal to L is your 40, 100 minus 40 is your 60, 40 by 60, that is your 2 by 3. R by S equal to 2 by 3. Now second part, if a resistance of 10 ohm is connected in series with R, so again this formula, R plus 10 by S, the null point is your 60 cm, that is your L is your 60, 60 by 100 minus 60, that is your 40. So it's your R by S plus 10 by S equal to 3 by 2. So R by S, it comes from 1, that is your 2 by 3, plus 10 by S equal to 3 by 2. So 10 by S equal to 3 by 2 minus 2 by 3. So if you take the LCM, it comes out 6. 9 minus 4, that is your 5 by 6. So 10 by S equal to 5 by 6. So if you simplify, you will get S is equal to 12 ohm. Now if you substitute S equal to 12 ohm in equation 1, that is R by S equal to 2 by 3. So 2 by 3 into S, that is your 12. So you will get 8 ohm. So two resistor we are getting, one is your 12 ohm, another one is your 8 ohm. So this is very simple, but provided you must have to know this formula. So sometime in exam it is asked, write the meter bridge in brief, regarding meter bridge in brief, or numericals. So in both cases you have to use the formula, and in both cases you have to show the formula. Now next topic which you are going to use that is your potentiometer. This is also very important from an experiment point of view. So what we have written, a potentiometer is a device that can be used to measure the EMF of a source without drawing any current from the source. So without drawing any current from that is very important part, and this one will become more clear once you go for the experimental point of view. So we'll discuss this experiment in our practical class. Now in the setup, you see a source is there, an emitter is there, a rheostat is there, that is RH. Rheostat is your variable resistance, and a key is there. So AB is your wire, and one voltmeter is connected with one end at A, another one is your free end. So what we'll do, we'll find the resistance for a particular length L by closing the key K. Okay, so mathematics part will come across, but before that, principle. So what is written? It works on the principle that potential difference across any part of a uniform wire is directly proportional to the length of that portion of the wire when a constant current flows through the wire. This is very important one, constant current. So potential difference across any portion of a wire is proportional to length provided constant current flows through the wire. So wire is here is your AB, and we are calculating the potential difference for any portion of the length AB. So explanation part, mathematics is very simple. So if V is the voltmeter and V is the value shown by the voltmeter for the length L, then we are going to use this for two formula, 1 and 2. One is your V equal to IR, that is Ohm's law. Another one is your R equal to rho L by A. So V equal to I, in place of R we are going to use rho L by A. So V I rho by A, that is your constant. If you consider current is constant because it works on the constant current, then V equal to constant into L, that is your length, where constant equal to I rho by A. So you can write V proportional to L, or you can write V by L equal to constant. V by L basically known as sensitivity of the potentiometer. So the principal part is here what? In potentiometer, potential difference is directly proportional to the length provided constant current flows through the wire. So more we will discuss regarding potentiometer in our next class, and please go through these two topics. It's a very important, and try to understand and make your habit to ask during the class. So this is all about. Thank you.